Hello students, today we are going to discuss chapter 3 coordinate geometry exercise 3.1, 3.2 and 3.3. First exercise 3.1 Introduction to coordinate geometry. Coordinate geometry is defined as the study of geometry using the coordinate points. Using coordinate geometry, it is possible to find the distance between 2 points, dividing lines in m:n ratio, finding the midpoint of a line, calculating the area of a triangle in the Cartesian plane, etc. There are certain terms in Cartesian geometry that should be properly understood. Next definition: it is one of the branches of geometry where the position of a point is defined using coordinates. It is one of the branches of geometry where the position of a point is defined using coordinates. Now write exercise 3.1, first question. How will you describe the position of a table lamp on your study table to another person? How will you describe the position of a table lamp on your study table to another person? Write down the solution. To describe the position of a table lamp placed on the table, let us consider the table lamp as P and the table as a plane. Now choose two perpendicular edges of the table as the axes OX and OY. Measure the perpendicular distance A centimeter of F from OY. Measure the perpendicular distance B centimeter of P from OX. Thus, the position of the table lamp P is described by the ordered pair AB. Thus, the position of the table lamp P is described by the ordered pair AB. See the diagram: x-axis and y-axis, lamp A and B. You choose any centimeter. Suppose A equal to 4 centimeter, B equal to 5 centimeter, means P is 3 and 5. Write down second question. A city has two main roads which cross each other at the center of the city. These two roads are along the north-south direction and east-west direction. All other streets of the city run parallel to these roads and are 200 meters apart. There are 5 streets in each direction. Using 1 centimeter equal to 200 meter. Draw a model of the city of your notebook. Represent the roads, streets by single lines. There are many cross streets in your model. A particular cross street is made by 2 streets, one running in the north-south direction and another in the east-west direction. Each cross street is referred to in the following manner: if the second street running in the north-south direction and fifth in the east-west direction meet at some crossing, then we will call these cross street 2, 5. Using the convention, find how many cross streets can be referred to as 4, 3. Second one, how many cross streets can be referred to as 3, 4. First one is how many cross streets can be referred to as 4, 3. Second one, how many cross streets can be referred to as 3, 4. Write down the solution. A unique cross street is shown by the point A 4, 3. Second one, a unique cross street as shown by the point B 3, 4. So the two cross streets are uniquely found because of the two reference lines we have used for locating them. Street x axis, y axis, x dash west and east, y dash north and south. X axis street 1, street 2, street 3, street 4, street 5. Y axis also street 1, street 2, street 3, street 4, street 5. First one is A 4, 3. So x axis 4, y axis 3. A point, B point 3, 4. X axis 3, y axis 4. So 3, 4. Next 2, 5. 2, 5. Draw a diagram. X dash and y dash, east west and north south. Next exercise 3.2, question number 1. Write the answer of each of the following questions. First one is, what is the name of horizontal and the vertical lines drawn to determine the position of any point in the Cartesian plan? What is the name of horizontal and the vertical line? Horizontal means x axis, vertical means y axis. Okay, horizontal means x axis, vertical means y axis. Draw a line determine between position on the Cartesian plan. So x and y axis. Second one is, what is the name of each part of a plan formed by these two lines? 4 parts there, so each part is called quadrant. First quadrant, second quadrant, third quadrant and fourth quadrant. First quadrant plus plus, second quadrant minus plus, third quadrant minus minus, fourth quadrant minus plus. First plus plus, second plus minus, third minus minus, fourth minus plus. So 4 quadrants there. Third one is, write the name of the point where these two lines intersect. Solution is origin. Write the name of the point where these two lines means horizontal and vertical. Horizontal lines x dash, y dash, intersect point is origin. Second question, see the given figure and write the following: the coordinates of B, the coordinates of C, the point identified by the coordinates minus 3, 5, minus 5. Next, the point identified by the coordinates 2, minus 4, the abscissa of the point D, the ordinate point of the point H. Seventh one is the coordinates of the point L. Eighth one is the coordinates point M. Coordinates of the point means x axis and y axis. Abscissa of the D means write x axis value only. Ordinates means write y axis value only. Now see the given figure. See x dash y dash. Point is given A, B, C, D, E, H, M. See, solution. First one is the coordinates of the B are -5, 2. Second one is the coordinates of Z are 5, -5. Third one is the point E is identified by the coordinates -3, -5. Fourth one is the point G is defined by the coordinates 2, -4. Next, fifth one is the abscissa of the point D is 6. Sixth one is the coordinates of the point H is -3. Next, the coordinates of the point L are 0, 5. Next, the coordinates of the point M are -3, 0. Okay. Abscissa point D 6. Ordinate point H is -3. Type X, abscissa x-axis, ordinate y-axis. Next, the coordinates L 0, 5. Next, the coordinates of the M are -3, 0. Next question, exercise 3.3, question number 1. In which quadrant or on which axis do each of the points -2, 4, 3, -1, -1, 0, 1, 2 and -3, -5 lie? Verify your answer by locating them on the Cartesian plan. Given points -2, 4, 3, -1, -1, 0, 1, 2, -3, -5. So 4 quadrant there. First quadrant, second quadrant, third quadrant, fourth quadrant. The point -2, 4, one minus x-axis minus, y-axis plus. So minus plus means second quadrant. Minus plus means second quadrant. So the point 3, -1, abscissa and negative. X-axis 3, y-axis -1. So 3 -1 plus minus. Plus minus means fourth quadrant. Minus plus second quadrant. Plus minus fourth quadrant. Third one is the point -1, 0 having negative abscissa and 0 ordinate. -1, 0. The point -1, 0 lies on the negative x-axis. Negative x-axis. Next, the point 1, 2 is having the abscissa as well as ordinate point. Both are plus plus. One x-axis plus, y-axis plus. So it is first quadrant. Next, the point -3, -5 is having the abscissa as well as ordinate negative. So minus minus lies in the third quadrant. X-axis minus, y-axis minus. So it is third quadrant. So the figure, Cartesian figure, A point -2, 4, B 3, -1, C -1, 0, D 1, 2 and E -3, -5. Take x, x dash, y, y dash, 1 to 3 up to 8, 0 to -7, y-axis 1 to 5, -1 to -5. Put the point A value -2, -4, second quadrant, minus plus. B is 3, -1, 3 -1 is plus minus, fourth quadrant. C -1, 0, -1, 0, it is negative x. D is 1, 2, both are plus value. So first quadrant. E, both are negative, third quadrant. So -2, 4, second quadrant. 3 minus 1, first fourth quadrant, minus 1 0, x-axis 1 2, first quadrant, 3 minus 5, third quadrant. Next question, plot the points x, y given the following table on the plan, choosing suitable units of distance on the axis x, y, minus 2 8, minus 1 7, 0 minus 1.25, 1 3, 3 and minus 1. So draw a diagram, x-axis, y-axis, x dash, y dash, 0 1 2 3 4 5, next minus 1, minus 2, minus 3, minus 4 5, y-axis 1 to 8, y dash, minus 1, minus 2, minus 3. First point 3 minus 1, so x-axis 3, y-axis minus 1. Second one is 1 3, so x-axis 1, y-axis 3. Next one is 0 minus 1.25, x-axis 0, y-axis minus 1.25. Next minus 1 7, x-axis minus 1, y-axis 7. Next one is minus 2 8, x-axis minus 2, y-axis 8. 1 unit equal to 1 centimeter, x and y-axis. 1 unit equal to 1 centimeter, x and y-axis. Okay, thank you.